My name, I'll put it down, is Linda Kavanaugh. And you don't have to call me Professor Kavanaugh or anything formal like that. You're welcome to if you want, but Linda is absolutely fine. Okay? So what I want to do for you today, come on in, Austin, is I want to get you a little bit familiar with how the course is going to be run, course expectations, what you need to do and how you get information, that sort of thing. So the first thing I want you to take a look at is the 3 packets in front of you. You have the pink sheet, which is a self-review information, and I think you can read this and understand what it is. But basically, in our textbook begins with chapter P. And P stands for prerequisites, which means these are the skills that you should have when you start this class. Now, I've been doing this class long enough to know, oh, you got to get the little dust off up there, and you may have seen certain things before, but you need a little bit of a review. So some of the things we'll cover, some of the things we won't. So this is a little packet that talks about these 3 sections, and this is the order that I talk about these 3 things. And the reason that I put them in an order, come on in and have a seat anywhere, is because P5, which stands for the section on factoring. Is that familiar to most of you, factoring? Okay. We're actually going to need to know how to do factoring for Wednesday's class. Wednesday's class is the last section in the chapter P called rational expressions. So those are like algebraic fractions. All right. So it would be really good if you could review and take notes on P5. Now there's a homework on P5, but that's not officially due until February 21st, which is our first exam. So even though the homework's not due, it'd be really great if you could, between now and Wednesday, look at section P5, take some notes, and do some problems. Now, well, you might say, what problems should I do? Well, let's take a look at the second packet here. Second packet is called your lecture note packet, okay? Now, this packet contains, for this week, contains 3 lectures for this week. So, and if you look up in the upper right-hand corner, you always know what class the lecture notes go with. So this is class 1, and today we're covering section P1. Now notice there's 3 parts of P1. If you look up in the left-hand corner, it says mathematical models. We're definitely spending most of the day talking about mathematical models. They also talk about algebraic expressions. I'm not covering that formally, but in our work today, we're going to do some algebraic expressions. And then you see real numbers. It says self-review after that. That means you should read section P1 and take notes on those areas as needed. Okay? Some of you may not need to take any notes on algebraic expressions. You feel pretty comfortable with them, how to evaluate them. So if you see something like 6x plus 1, the whole thing squared divided by x minus 9, and I say evaluate that for x equals 6, you throw 6 in and you find the number. You might feel comfortable with that, so you don't need to take any notes. Okay, so this is really like based on what you need to do. Now, if you notice, class number 1 goes for 1, 2, 3, 4, back 2 pages, and then you come to the section that gives you your homework for class 1, okay? So notice it says self-review is the very first thing you see on the top, because that's the first thing I want you to do. And it says prior to class number 2, it's important to review and work through some of the examples in the factoring section. And these are what you should be familiar with, these factoring techniques. Now, if you just turn the page one more time, you see the beginning of class 2, and I've given you some examples of the type of factoring that you should be familiar with. So you might look at, like number D and say, no problem, I can do that. But you might look at J and say, I don't remember doing sums of cubes, perfect cubes. So you go back to P5 and they give you a formula for that. So I've shown you some of the problems you should be able to do before we start. Right at the bottom on Wednesday, we're going to start with rational expressions and domains. That's where we'll start on Wednesday. So here's the nice thing about this course. Let's suppose you start to review your factoring and you say, God, I need help on this. And let's say you can't come in on Tuesday because you don't have classes on Tuesday, or you have childcare, or you're working. Well, you can come to the studio with some questions on Wednesday before class even starts, right? You have 10 to 10:30, 10:35. You can be in there working with me or Jean Reese, because I'm always there on Monday, Wednesday, Friday, 10 to 10:30. Okay? So don't save all your questions for them, but you say you have 3 or 4 questions and you need a little more help on factoring, that's why I'm there to help you out. Okay? There's lots of help available at GCC for math, well, for all students, but particularly for math. The studio is fantastic. It is staffed most hours through the entire day from 8 to like 5, 5:30. You have peer tutoring, which is free. We also have this online tutoring system called Smart Thinking. And you have me. So what more could you ask for? All right. The one thing I don't want you to do when you need help is to do the following. Where is it? Oh no. Come on. It's not there. Oh, here we go. This is the one thing I don't want you to do. Oh no, that's not it. No, that's not it. Where is it? Here it is. Pretty good, don't you think? You tell me. So anyway, that's one avenue of help I'm not recommending. So anyway, all right. So P5, as you see, is something that you should be thinking about between now and Wednesday. Now, on your syllabus, which is, come on in and have a seat. 2 seats over here. On your syllabus, this syllabus tells you sort of, it's our contract with each other. It tells you about this course, what the objectives are, what to expect in class, and what I expect in class, the resources available to you, some different things on technology. It tells you how you're going to be graded, and it gives you grading options. This is probably new to many of you. I give you 2 ways to be evaluated. So if you're one of these students who says, you know, I know when to do my homework. I don't really do well with deadlines. Please don't make me do my homework by a certain date. I'll be responsible for it. Then you will be a test-heavy person. Homework counts 0%, and you say, I'm a good test taker. I'm not really concerned about doing all this extra stuff. Other people say, oh my God, you know, I'm never really good at tests or quizzes, but I do my homework, and I really wish that would count more. Well, you see, test light is 20% of your grade. So you have a chance. you are in total control of 1/5 of your entire grade. That's pretty generous if you think about it. Notice your homework counts more than your final exam, 15%. So you don't have to make up your mind. I ask you to think about it until your first test is February 21st. So if you're not sure what you're going to be doing, I would suggest that you start doing your homework and get a feel for it and how you're doing, okay? Now, your homework, the schedule for your homework, it follows this. This is your schedule for the entire semester, okay? And unless for some reason we need to change it, this is what you can expect. You have 6 quiz dates, 3 exam dates, and your project due date. So you have plenty of notice as to when everything is. So saying when there's a quiz, well, I just didn't come that day, or I don't know, well, that doesn't fly, okay? So you know when you have to be here for your assessments. So I hope that you can make it. Unless there's like rare circumstances, very rare, will I give a makeup, very rare. So and I dropped the lowest quiz. So the first time you don't make it, don't even tell me what the excuse is. There's a second time, then you better talk to me, because it will be a 0 that gets counted. Okay. So my math lab, the last sheet, this is how you're going to do all of your homework. You can get lots of help on my math lab. It's also going to provide you with the opportunity, if right now you're broke and you don't have any money to get a textbook, whether that's your e-textbook, which means it's all online, or whether it's this gorgeous little thing right here, this soft covered book that Amy, is it Amy? Yeah. Amy has. Yep, there it is. So it's a 3-hole punch, and it's in color, and it's just like a hardcover book, but guess what? It's a lot cheaper. Now, some people really like having something physical to like turn the pages and write in. They don't like the e-textbook. That's okay. You can get one of these. You have the option of an e-textbook, which is available for a couple of years for you. Or for some reason, some people still like getting a hardcover textbook, but those are the most expensive. So the good news is when you sign up using what did I just do with that thing? Thank you. When you sign up with my math lab, you just need, the main thing for you to tell my math lab is that you're in this course is number 3. It says Kavanaugh 71748. That's your course ID. That's what you need to sign in. Now, the good news is, starting today, you have 17 days to hang out on my math lab without paying anything. They give you free access for 17 days. And this is really good for folks who are out working and say that their check hasn't come in or won't come in to next Friday, or your financial aid hasn't come in yet. So this gives you a little leeway financially to still start your class on time, to still have access to the book and the homework, okay? So my math lab, I just want to give you a real quick intro, because pretty much you're going to be doing this and you'll figure it all out yourself. Let's see. This is not what I wanted. Here we go. Recording learning guide, YouTube. Oh, let me talk about YouTube for a minute. So when you put Linda Kavanaugh into YouTube, the first thing you're going to see is this woman. She's probably my age, but she has like blonde hair and it's kind of short. She's like some kind of newscaster or something. You got to scroll down a couple of blocks and you'll see my name with this little kind of blue figure. I haven't put my photo in there, but maybe I will one of these days. So all of these classes, like right now, this is all being recorded. And there's a link in your Moodle site that will take you directly to our playlist, which is Math 107B. Or I might just have it be Math 107. I think this year I just did Math 107, and you'll see Section A and Section B. And it will always be by class number. So you'll see Class 1. And right now I'm uploading the class, my previous class. It's in there now being uploaded, but it hasn't come in yet. So notice when you come in here, you see some class videos, one on the self-review for section P2 in the book. This is actually from last semester's class. So when you click on this, your notes for that class are right here in your pink sheet. Notice it says section P2 and P3, and then you have some exponent problems. So everything that you may need to review is on YouTube if you want to listen and watch me work through them, okay? But this is where we're going to be for this spring. Notice, can you see right here, it says Class 1B, Fall 13. I just put that in from last semester so that I could create the shell for you to put in your videos. So if you click on this, let's suppose I forgot to put your video up. This is from last semester. It's pretty much the same lecture we have right now. And so why, one of my students said to me, why do you do that? And I said, well, sometimes students can sit through class and they may understand something, they may not, they may need to review it later. Sometimes I know it won't happen often because you're going to love me so much, you're going to want to come to class every single day. But if you miss class, this is a way you'll have your lecture notes. This is a way you can, before you come to the next class, no excuses, right? It's right there, and it will be right there. So you can listen to the class, fill in your notes, and be prepared for the next class. So that's available to you. Now, I was going to go into what? So here's our Moodle site right here. It has a gorgeous knot. If I ever had a tattoo, that's what I'd want. But one of my students last year told me her father was a tattoo person. She said, you know, that's like impossible with all those colors changing and everything. That would cost you a mint. I said, all right, never mind. Plus, of course, I want it right here. She said, that's like the most painful area. So I said, all right, never mind, twice. Okay. So the Moodle site is where all of our sort of like official course documents are located, like your syllabus and other things like that. It'd be really good for you to make sure you check your GCC email, because if I make any changes, I put them right here in class announcements, which will come to your email. The lecture notes you have right now are in this folder because you'll be getting lecture notes for test 1. Then when we have test 1, you'll see another folder here that says test 2 lecture notes. So that way you can group things, like when it comes for the final, you'll know where your lecture notes are based on what part of the semester we had the material in. Here's your link to our class videos for this semester. Here's your link to a review on exponents and scientific notation. And here's a link to radicals and rational exponents. Let me just say, this link will probably be the most used self-review because people forget. What does it mean to say 8 to the 2/3 or 8 to the negative 2/3? I forget that, they say. So here's definitely what you want to check out, okay? So that's our Moodle site. The other things you'll see is I'll have quiz solutions after we take a quiz. I'll have all the solutions to the quiz here. I'll have some test prep videos, study guides, and then video solutions for the study guide. So all that will be available on Moodle. Cooper? I don't do test corrections. How's that? Okay. No test corrections. All right. But I would, if you wanted to do test corrections and have me look it over, I'd be glad to do that. Okay, so here's my math lab, and this is what your homework section looks like. And I noticed today that class 3 was missing. I was fooling around with this last night, trying to watch the Grammys and all that before Downton Abbey came on, and somehow it disappeared, but I'll find it. So notice the due dates for all your homework are right here. Okay, notice your self-review stuff. The 3 self-reviews aren't due to 2/21. I'm encouraging you to start this today, tonight, tomorrow night, you know, before the P5. This is an orientation. It's optional. It won't count if you don't do it. It just kind of shows you the different types of questions you can get in my math lab and how you answer them. Notice every class the homework from that class will be due generally the next class. But look, the first week, I'm not going to have you do tonight's homework by Wednesday because some of you don't even have the book yet. You got a lot going on this week. So today's homework won't be due until Friday. Wednesday's homework won't be due to Monday. So the first 2 classes, I'm giving you 2 days. But then the 3rd class, which is in here, will also be due Monday. So generally your homework, most of the time, is due the next class. And to get 100%, you have to do your homework by that next class, by 11 o'clock a.m., okay? So let's say you've got a couple of exams going on and you're focused on this research paper you have to write. and you have homework that's due on Friday, and you got all of it done except for 20 points. Well, so you've got 80, let's say, 80% done, you'll get that full 80%. The last 20% of that, let's say you have 10 points, make it easy. You have 10 points you didn't finish. You have until 2/21 to finish those 10 points. Anytime between when it was due and the appropriate test, and you'll only have a 20% penalty. So if you had 10 points and you do those 10 points, you'll get 8 out of 10. Okay, so that gives you leeway if you can't finish all the homeworks because you got other stuff going on. Your final due date for any homework is always whatever the next test is. That's the final due date. Is that clear to you? Okay, I hope so. But all you have to do is check here, and this due date is to get 100% of credit for 100% of your homework. Okay. Now, there's other things in here you should check out. There's this, I'm just going to quickly show you. This learning guide is really neat. I didn't have this available last semester, but it is available this semester. So if you go to Chapter P, here's the very first section we're covering today. And what the learning guide does is it breaks the section down into every single mini objective that you're taught in that section. It gives you a problem all worked out on this side, and then it gives you one to check out and try on your own. So this is a way you can sort of do a little self-assessment. Oh, I've got that down, no problem. I could use some more help. I better talk to Linda or go see someone in the studio. Okay, so that's available to you. You'll probably want to use those, particularly before one of your quizzes, to kind of go through and check out each objective. There's a lot available to you for help. And also, what I didn't show you is in your homework. Where's the homework? In your homework, what's really cool is if you go to your homework, you see how there's these 1, 2, 3 little video things. So if you're having a problem with a particular problem, you click on that and someone is showing you how to do it. They talk to you and they write it out. It's like a video of the problem. And even if it doesn't have a video, they show you a similar problem all worked out. It's just not an audio video thing. It's just, it's like step by step. So students really like this feature of My Math Lab. It really helps them out in terms of when they have to work out problems. So again, you'll explore this, you'll be doing this. I can see everything you do, okay? So I'll know like Wednesday when you come to class how many of you have gotten on, what you've tried, even if you've done a homework assignment or you haven't even downloaded it yet. So I'll have a sense of what's happening by Wednesday. Yeah, Amy? Yeah, I think no, I think what happens is, let's try this out. I think you have 3 chances to get it right, and then they give you another problem. So, I wanted just one with one answer. So here's one. So here's evaluate this expression for x is 9. So I put in 13 to show my first class. It's wrong. So let's hit it. Check. Oh, sorry, that's not correct. They tell you what to do. So you try another. I hope I don't get the right answer. Oh, they're giving you a final check. Sorry, that's incorrect. So I think now what they're going to do is they'll give you a similar exercise, and then you just get a new one to try. So let's say you try it. See, I tried it 3 times because I tried it once with my class and twice with you. So you have three chances to try a problem. If you get it incorrect, they'll give you a similar one. But let's say somewhere after your second try, you wanted to view an example. See, this is what I mean. It's not a video, but here's an example similar to that one. You hit continue. It shows you the first step. You hit continue again, shows you the second step, and it shows you how to do it. Okay? So there's lots of chances. You can keep going as long as you want. Now that's marked X because I haven't done this yet. So let's get this correct. So we put 3 in. We get 2 times 6 is 12. 30 minus 20 is 10. 12 divided by 10 is 12 tenths. But I got to reduce it 6/5. So I've got to make it a fraction. So I go over here and I put in that and I say 6, enter, 5. Whoops, I didn't say enter. 5, enter. Good job. And then it will change that X to a fraction. Okay, Jonah? Yeah. Right, and that's why when you read your syllabus, I said, always print out your homework. So if there's ever an issue like my math lab freezing up, or you know you got the right answer, but you just haven't figured, sometimes it's a little picky about how it wants you to answer. So in other words, if you have to do a list of numbers, they always want you to start with the smallest to go to the largest. So let's say you didn't pick that up, right? And you got the right answer, you just show me, and then I can go in and change your score to anything I want. So don't worry, just talk to me about it, like with the situation Joan is talking on.
So is it listed at the end and you can print it out?
Yeah, you can print the whole thing out before you even start and just work it all out, and then put your answers in. And the problem is, folks, if you do it all online and you don't keep any record of what you're doing, you don't have anything to study when it comes time for your quiz, right? So it's really good to work your homework out and have it, like a little homework section in your notebook. All right, that's enough for that. I want to kind of get going with today's lecture. What I don't do is I don't go through the syllabus, because to me, the worst thing to do is to have a teacher stand in front of you and tell you what's on here when you can read it. So one of the first things, your first homework assignment says, if we go now to the end of class lecture 1, I think it's like the 5th page in, or depending on how front and back, it's like the 5th page. Notice it says right here, read the syllabus. Answer the following questions and turn them in class 4. Class 4 is next Monday. So next Monday when you come in, you're going to have read your syllabus. You're going to answer those questions, and you're going to put them right in here with your name on it. I'll read them. I'll address any questions that I didn't make clear in the syllabus. And I use that each semester to update and try to make my syllabus as clear as can be. So you put it in here, I'll look it over, make some comments, and give it back to you in this little folder. This is like how we communicate with each other throughout the semester. So check this out. If you pass anything in, that's where I'll pass it back to you. Okay. So did I steal something from somebody here? That's your lecture notes? No. What, your syllabus? Okay. All right. So any questions before I officially start with today's material? Anybody? Yep. Calculators, thank you very much. In fact, I have it right here, so I didn't forget. And I forgot. TI-83 or plus, or TI-84 graphing calculator. All my materials in the book is written for TI-83 pluses or 84s. If you get an HP or a Casio and you're asking me what to do, I'm going to say, get your book, because I don't know. All right. But if you have one that's a Casio or an HP and you know how to use it, great. But you'll need your manual for me to help you. Let's suppose you don't have any money to buy one of these things. Graphing calculator rental program. We've had this since, when did I actually got this going? Back in, I think, the late 80s, early 90s. And it's been going for many years. So that will help you out with that. Someone said, can I use my phone? Absolutely not. In fact, that reminds me, if you want to quickly get on my side, have that phone go off in class and pull it out of your pocket. When I get more. So make sure your phone is off. Make sure, for those of you, I saw this once in one of my night classes with, literally, I had a student that could not put her phone away, and if she put it away, she kept pulling it out. It was the first time when people talked about students becoming addicted to texting and stuff like that, but I saw it before I was like, oh my God, this is serious. So one of my students who had me for 2 semesters used to keep it in his pocket and used to sit right there. And every once in a while he'd pull, I said, come on, Shane, come on. He's like, I know, Linda. So if you're tempted, put it away into the deep recesses of these beautiful backpacks you have, okay? Don't have it available, okay? However, if you're on call for something, you're a safety personnel, you have kids that are sick, and you need to keep it on vibrate, that's fine. Just let me know if there's any issue, no problem, okay? It's very distracting. So my model is be here now. When you walk through that door, you're here. Before you walk through that door, you're welcome to do all the texting you want outside of the classroom, talking on the phone. Please don't talk on the phone in the studio either. But when you walk in here, you're coming in to be present to Math 107. Question? Someone started to raise their hand? Okay, let's talk about math. Go ahead, start us off, Megan. Read number 1.
A common refrain heard when teaching mathematics is, when are we ever going to use math in the real world? Answer.
Okay, so let's take a look at this bar graph. And this bar graph shows the average cost of tuition and fees at public four-year U.S. colleges. If we had another graph superimposed with private, you can imagine how much higher they'd be for private. This is adjusted for inflation. So a couple of things I want to point out here to you. Whenever you present a graph to me on a project or whatever, please make sure it has some type of title. Make sure your axes are labeled. And if you do not start at 0, if you start any of your scales at a number other than 0, see this like little squiggly line here? That's called a break in the axis. So in other words, if you had started this at 0, this would be way up there. And so basically they just did a little snip in the axis and brought it down. And sometimes if you take a stats course, that's one of the ways you can take something that looks relatively flat in reality and you can sort of distort it. And so there's a little famous book called How to Lie with Statistics. So you have to do this little break if you're not starting at 0. Now, this description of this right here is very weird, and I'll talk about that in a minute. But right now at your seats, I want you to spend a few minutes looking this bar graph over, writing down on your own a few observations, and then I'd like you to compare it with your table mates. And when you're done, when everybody at the tables had a chance to write a few things and talk, put your little flag up on your table, that little black flag. All right, just throw it up there and I'll know when you're all. Okay, so this is table 2's comment. One of the students says it looks for the most part linear, and someone said, yeah, almost linear. So do you have something you want to add to that? Maybe some of you already wrote that down, but maybe some of you noticed something else. Connor, what did you notice? Right, so the average cost has more than doubled in 10 years, yeah. So that means the rate's about 7% a year, okay. Is anybody curious how I came up with that? About 7% a year for it to more than double in 10 years? Nobody's curious? Right, fine. It's going to teach you a little rule of thumb, but that's all right. Okay, about another table. Table 3, did you come up with anything different than that? Nothing? That's the only 2 things you have? Didn't notice anything else different? Okay, so positive rate of change, yep. Oops, I heard something. Okay, table 4, how about anything else you want to add? No? Right, biggest increase, largest, biggest increase. That's why we can't say it's linear, because the increase is not constant from year to year. It changes, it's variable. Biggest increase in the average tuition was between 2003 and 2004, right? So you put a little dot right in the middle of those bars and you connected it with a straight line, that line segment would be the steepest. It would have the largest slope. If you found the slope between those 2 points, it would be the largest between any other points. It's the steepest line. So the rate of increase there is the largest or the biggest. Okay. And do you have anything else to add, table 5? I'll start off with you guys next time, okay? All right. So we've already talked about this little symbol that shows the break in the axis. So if you pass in a graph and you don't start at 0, you'd want to put a little break in the axis. So some people might be saying, well, wait a minute, this starts off with 2000. Why isn't there a break in the axis there? And the reason there isn't is because of the way they've described that axis. And it's really weird when you read it, you think, Linda must have made a typo. Ending year in the school year. Ending year in the school year. Well, here's the school year 2000. What's the ending year of 2000? All right, let's try 2005. What's the ending year of the number 2005? 5. What's the ending year of 2004? What's the ending year of 2000? 0. So it actually is starting at 0. And in fact, in a minute when we use the model, that's how we're going to define our independent variable. We're going to say let x be the number of years from the year 2000. So the year 2000 is the first year in its own. Let me say this. The year 2000 is the initial year. That's the year we start with. It's 0 years from itself. So that's your 0 point. This would be like your y-intercept if we scoot that over. Okay. All right. So I'm going to skip this next thing and this next question. The good news is that it may be possible to answer any question you might have about future rates for tuition and fees. And to do that, we collect data like we've just done, and we create a mathematical model. Okay, now this model doesn't give us the exact answers for any particular year, but if the model fits your data well, it's going to be pretty close to the actual data values. Okay, a model is a mathematical representation. It could be an equation, it could be a formula of a real world situation. We can describe the relationship between two or more quantities. We can write an equation relating them. This is an important step in problem solving, being able to convert a description of a relationship to an equation. So some of you already said, well, maybe I could use a straight line to model this. So maybe if you picked a straight line, you might be able to do something like that. Or maybe you say, no, I think I can do better than that, Linda. So you might grab this thing and move it around and tilt it or whatever. You might say, well, that might be a good straight line. There's an infinite number of straight lines you could put through that particular data set. There's only one that's the best. We're going to learn about that in a couple of classes, a couple of weeks. So that would be, you would be able to get the equation of this line, and the equation of this line would be able to predict a tuition in an average tuition cost for any year, okay, if you had the equation for that line. Well, believe it or not, the model that best fits this data is a parabola. It's like parabola, and every time I try to draw it with this free crayon here, I mess up. But if you can imagine this 1/2 of a parabola going through that data point, that's what this model is right here. So this model, you notice, is an equation. It's predicting the average cost of tuition and fees. That's what T is. That's your dependent variable. T depends on the value of X that you put in. So that's always going to be your vertical axis variable. And we call it the dependent variable. So T is our dependent variable. You tell me a value for X, and then I know what my value for T is. I have an identity. So the model that we use is this equation. Whatever the value for X is, you square it, you multiply it by 4, blah, 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 blah. So this side of an equation is an expression. So once we plug a value in for X, we're going to be finding the value for that expression, and that's going to equal the tuition. So let's see how we're defining what X is. It says the formula models the average cost of tuition and fees, called T, for college years ending X years after 2000. So we had the years 2000, 2001, up to 2010. So the value for X will be 0, 1, 2, 3, 4, up to 10, okay, based on the year. So notice my data my actual data that I've collected that this model is fit to, goes from 2000 to 2010. So anytime you use a model to find an estimate, and you're using a value of X that's part of your actual data set, it's called interpolate. So we're going to interpolate right now because I want you to use this model to find the average cost of tuition and fees for the year ending in 2010. Even though we know what it is, let's see how good our model estimates it. So first of all, you need to know what to plug in for X here. What are we going to plug in for X? 10, because 2010 take away 2000 tells us that it's 10 years after 2000. So I just use my model and I plug in 10 for X, and I evaluate the expression on the right hand side of this equation. And what do I get when I do that? I know some of you have already done it. 7,004. Do I have agreement on that from anybody else? Nobody else? Nobody else? All right. I'll have to call up my handy dandy calculator here and do it myself then. Okay. Let's clear this out. 10 squared times 4 plus 341 times 10 plus 3194. 7,004. How could I doubt you? Okay. So that's what this model estimates. This is an estimate. Now you can compare it to what the actual data was by looking at your bar graph. And what was the actual data value for 2010? 7,020, right? Okay. So is 7,004 an overestimate or an underestimate of the actual value? It's slightly underestimated, right? So it's an underestimate by $16. Okay. So if your model's a good model, it should be really close to modeling your data that you've collected, estimating it. But often people use models for predictors to try to predict outside of your actual data range. And that's what we call extrapolation, when you go outside of your data. And you got to be a little bit careful when you go outside your data set. If you go outside too far, your model may not be accurate anymore. So a lot of times, if you're the researcher, you know your data pretty well, and you know sort of like what's happening with the particular population you're looking at or the particular problem. So what I want you to do, tables 1 and 2 and 3, I want tables 1, 2, and 3 to find the average cost of tuition for 2014, and I want tables 4 and 5 to find the average cost of tuition for 2050. And when you're done, put up your flag. Okay? Okay, so these are the two answers as we go out. Now think about how a parabola grows. So a parabola grows like that, and think about the difference on the same data set with a line. Okay? So you can see that if you go out too far, your quadratic model may really overestimate it, right? We don't really know. I asked students if they think this is plausible. Do you think saying that in 2050 the average cost of tuition for a four-year school is $30,000, you think that's plausible? Yeah, some say no, some say yes. Jonah just said depends on the economy. You know, who knows? It's really hard to know. However, sometimes you will use a model and you'll plug in a value outside the data set, and you'll know there's no way. Now remember, we could have gone back into the past or we could have gone into the future with this. You know from plugging in that value, there's no way it was right. Because sometimes you could end up with a negative number when it's not even possible. So when you extrapolate or you go too far outside your data set, this might be a new term for you. We say that you have model breakdown. So you got to be really careful when you try to estimate or predict outside of your data set. Sometimes it will still seem reasonable to you, and that's okay, but sometimes you'll say, wait a minute, Linda, my model is predicting something I know can't be true. So model breakdown has occurred. Okay. All right, sets, not the other word, sets, S-E-T-S, all right? That's what we're going to talk about next, okay? And I'm going to go fairly quickly because we, believe it or not, we only have 20 minutes left. Sets, what is sets? It's a collection of objects. One way to represent a set is to list all of the members of that set, or what we call elements. So I can let capital A stand for the set of the Three Stooges. And since there's only 3 of them, I can list them. This is called the roster method. Most important thing I want you to remember about this roster method is this little thing right here, the symbol. This is a way we indicate a set. So if you want to list members of a set, you have to include these braces. It's a grouping symbol when you're in basic algebra, or you could call it a profile, like there's your nose and your mouth, whatever, you're not happy, I don't know, and there's your eyebrow, whatever. It's not a parenthesis and it's not a bracket, it's a brace. So that's how you indicate a set. Now, here's a fun one. I want you to represent the set of 7 dwarfs at your seat, and I want to see who can do it. Which group can do it the fastest? Here we go. Go! First of all, the capital letter B is representing the set. What do I do after the equal sign? What's the first thing I do? The squigglies, the braces, right. Okay, slow, don't go. My last class, the person zipped them off, and I said, I can't write that fast. Okay, so I heard happy. Go on, happy. Dopey, one of my favorites, yep. Grumpy, never.
Sleepy.
Sleepy. Doc, bashful. 1, 2, 3, 4, 5, 6. And sneezy. All right, there you go. Those are the 7 dwarfs. So what's important here is this is called the roster method because you can list it. That means it's a finite set. When we're talking about numbers, however, if I asked you to write all of the numbers greater than 2, you can't do it. So I don't even know what the next biggest number is after 2. I could say 2.000000001. You could say 2.000000001, right? I can't tell you the next real number bigger than 2. So we got to have another way to talk about sets of numbers that when we can't list them because they're infinite. So we use another method. It's called set builder notation. Set builder notation. And a few classes you're going to be learning another method called the interval notation, but right now we're going to work on set builder, and it's a little scary when you first look at it. And the way you do set builder notation is you start with the same thing. You start with your braces and you talk about whatever variable you're using. In this case, let's say x. And let's suppose I wanted to represent all numbers greater than or equal to 2. I would say braces x, and then I put a straight line like that, and we read that such that. And what goes on this side is some kind of either statement. You can literally write out all numbers greater than or equal to 2. You could write that out in words, or you could represent it mathematically with an inequality. And the way I would do that is I would say x has to be greater than or equal to 2. And now I've represented a set of numbers that's infinite. I know how I get into this set. If I'm the number -1, do I belong to this set? Am I a member of that set if I'm -1? No. How about if I'm 552? Am I in this set? Yeah. If I'm the square root of 49, am I in this set? Yes. Okay. So this is how we use set builder notation to represent sets of numbers, particularly that are infinite. You should always be able to test. We just tested that statement. I gave you some examples and you tested how you get into this exclusive club. You have to have this property. All right. Okay, so union and intersections. How timely is this? Anybody watch the Grammys last night? Nope. Yep, one person. Okay, well, I have no choice because I have a 14-year-old, and it would have been disaster if I said, no, you can't watch the Grammys. Well, I did get her on to something else so I could watch Downton Abbey at 10. But anyway, it was great last night because around 10 something, Paul McCartney and Ringo Starr, 2 of the original Fab Four Beatles, did a little, I guess Paul McCartney has a new song out, but February 9th, 1964. Now, I know some of you were just a glimmer in your parents' eyes at that point, but I was, well, how old was I? I was 8. I was in the 3rd grade, and I remember sitting with my cousins in front of a TV set to see the Beatles on the Ed Sullivan Show. It was crazy. And all I remember, I was sitting there, and I was like, why are all those girls screaming and crying like that? I couldn't understand why the audience was going crazy. But of course, this was a big phenomenon. And February 9th, CBS is doing a 50-year anniversary of this. So if you don't know anything or much about the Beatles, watch that. I'm sure you'll catch on to it. No, I didn't. Oh, I hope this is as good as that probably was. Okay, so here's a little story for you. I'm walking up a road in Prince Edward Island last August, and I'm thinking about writing these lecture notes because we change books. And I said, and by the time I got to this point in the lecture notes, I was like, oh, I put 2 sets down, and I said, what's the union and intersection? And I'm walking up the road, and I'm like, that's really boring. I should be able to come up with something better. So this is what I came up with. Hope you like it better. So who wants to read? Connor, you want to start number 8 for us? Doesn't he sound like he should be a DJ? I met Connor at Staples about 3 or 4 weeks ago, and I said, you should be a DJ. Great voice. Okay, go ahead. That's why I picked you for this one, Connor. All right. All right, so set A, those were the Beatles that were in Hamburg, Germany, and doing all these nightclubs. And if you've read the book Outlier by, what's his name? Gladwell, Malcolm Gladwell, he talks about the Beatles. And in that book, that he says that to master anything, you need to invest 10,000 hours. So I'm not expecting you to master Math 107 by the time you leave this semester, right? 10,000 hours, I don't think it's possible. Does anybody get a sense of how many years that would be? Oh, you can figure that out while you're in the shower or driving home. Okay, so I like to do these little mnemonic things to help you try to remember stuff. So I want you to imagine that we're going to list all members of the Beatles above. No, I want you to imagine that all members of the Beatles above are still alive. They're not all still alive, but I want you to imagine this. And we're going to plan a reunion. Notice I'm underlining union. Reunion. List the members who would come to the reunion and label that as set C. So I'm going to write what you tell me. So tell me how I start off here. Phrases, thank you. Cooper? And then Ringo Starr. Okay. So notice, even though John Lennon, Paul McCartney, and George Harrison were part of both groups, I didn't list them twice, right? I mean, you can't show up twice, right? You're one person. So this is what we call the union of sets A and B. And this is how we write union mathematically. It has this little U, just like that. Okay? And it says A or B. So you're a member of either set A or B. And if you happen to be in both, then you just list it once. So later on your own, I want you to write in your own words how you form the union of 2 sets so that it makes sense to you. You can use this example, or you could write some number sets down, but write it out in your own words so it makes sense to you. And if you're not comfortable with that, then copy what the book has, okay? This should be what makes sense to you. All right, the other type of thing we can do with sets is we can find the intersection of 2 sets. And that's denoted by this symbol with the U turned upside down. So the intersection of these 2 sets would be the members of both of the bands, the members of the 1961 and the members that are also in the 1964 bands. So that would be someone else other than, how about Austin? What members are in both bands, Austin? Yep, George Harrison, that's it. Okay, So that's the intersection of those two sets. So you can write in your own words. That's why I have this little icon there to write in your own words how you might represent the intersection. Okay. Any questions on that? Union, reunion, and intersection. All right. Okay, so we got a couple more things to cover before the end of class. And this appears in section P1. I think most of you are familiar with absolute value. So, but you may not be familiar with the official definition of it. So first of all, I want you just to take a few minutes at your seat and review this definition, and then discuss the following question with one of your neighbors. Does this definition mean that the absolute value of a number can be negative? Why or why not? So look it over and have a little discussion. Okay, so let's have a little come back together and discuss this. So what do you think I'm trying to get at here? So first of all, does this definition mean an absolute value can be negative? What do you say, Gina?
I think an absolute value cannot be negative. To me, the definition of absolute value is how far it is from zero.
How far? So an absolute value, thank you, talks about distance, and distance can never be negative. So does this definition say that we have a negative number somewhere? What is this? That looks like a negative number to me, that little dash in front of x. So is it saying this is the true definition? So what's going on here? That looks like negative x to me. It must be a negative number, right? But it's telling me that the answer is negative x. What? Yeah, distance is always positive. So what's going on here with that? So how do I know I have a negative number here? Yeah, folks, look at the statement after it, right? They've said the absolute value of x isn't just x or the opposite of x. When you put this in front of something, it says take the opposite of. -1 times any number takes the opposite. That's what's really going on here. But notice the little statement after it. You only get to be defined this way if you're what kind of number? 0 or positive. So this is called non-negative. So when you go in between these absolute value symbols, you are already a non-negative number. So when you come out, you look exactly the same, right? But who gets to go in when you're down on this line? Who goes into here? What kind of number? No, right here, this. X less than 0. What kind of number are you now? You're negative. So when you go in, you're negative. A little plastic surgery is performed because when you come out, you're what? Positive. This represents a positive number. Why? Because this means you're the opposite of x, and x is a negative number. So that means you're positive. So in both of these cases, the result is positive, but we have to break it up into two statements. Later on, when we get to chapter 2, in section 2.2, you're going to learn this as a piecewise function, is what we're going to call this. Because we broke the definition up into two pieces. We had to talk about this definition based on two parts of the number line, okay, in order to define it. So the next thing you have, number 10, you have 3 statements. I want you to write always true, sometimes true, or never true beside it. When your group has decided, put up your flag. Let me just say that these results were very similar to my first class, except for in my first class, question 3 had 4 sometimes and 1 always. So very similar. I don't think we need to discuss these two since we're in agreement. What we may need to discuss is to make sure you read the rest of this. It says, if you write sometimes or never true, either change the statement so that it is always true or show a counterexample. So for those who put never here, how did you change the statement? What did you write here so that it would always be true? Cooper? Oh, you made it the top one. Okay, what's another way you could change it? How could you just change this sentence so that it's, yeah, just change that to positive, right? So these are the types of things I throw in on quizzes and stuff like that. So I want to give you, you won't see these types of questions in your homework, all right? All right, What's going on in number 3? Why do some people think it's sometimes and some people think it's always? So someone from the sometimes group want to argue sometimes? Yep, Gina?
Well, if the value of A and B are the same,
All right. All right. So let's assume that A and B, because I've used two different letters, that they're representing two different numbers. Otherwise, I would have said A equals B. So what if A and B, because if they were the same, I'd have to say A take away A and A take away A, or B take away B. So those are two different numbers. Do you want to keep it as sometimes or always?
can A or B represent a negative?
Yep, it can be anything.
Okay, so if you have -3 minus 3.
-3 minus 3 on this side. So that's A is equal to -3 and B is the number 3. And then on this side, it would say 3 take away -3. Yep. This one would be -6. This one would be +6. They're equal. You're looking at the number -3 and 3. What's the concept you told me, Gina, for absolute value?
Absolute value is
Distance from 0, or when you're subtracting numbers, it's the distance between the numbers without regard to the order or the sign. -3 and 3 are 6 units from each other. If you subtract them one way, you'll get -6. If you subtract them the other way, you get 6. But if you're talking about their distance, the distance doesn't change. So the absolute values are always equal when you subtract, you change the order of subtraction. See you on Wednesday. Have a great